All right, hey guys, we're trying this. I've recorded this way too many times because I keep messing up. So today we're going to do growth and decay again, but we're going to do a little differently. So we're actually going to solve things today instead of just identifying them like we did the other day. So remember, if it's a growth, okay, that means it's going to be an increase. Okay, and that number that's being raised to the power is going to be greater than 1. And if it's a decay, that means it's going to be a decrease, and that number is going to be less than 1. Remember, no negatives allowed, right? Okay, so you guys had problems like this on your work that you did. Hopefully everybody did it and turned it in. It was due last night, okay, Sunday night. So 3 times 4.5 to the x power. So what we were doing is we were focusing on this number. Now, this is a growth, but that's great and all, but I need to worry about this number in here. Okay, so that number in there, guys, what that is, wait till that goes away. Sorry, I wanted to make the screen bigger. Okay, that is called the multiplier. That's the number we're actually going to be looking for today. So we're going to do some work with that, and then we're going to solve some problems. So we're going to look for that multiplier number over there. Maybe if I move me over here. Okay. All right, I'm trying to get this shadow out from on this side. All right, so here we go. We're going to find the multiplier. Okay, we're going to start with growths, because those are a little easier than the decays. People tend to have less issues with those. So when you do a growth, you're going to do 100 plus the percentage, and then you're going to change it to a decimal. Okay, so if I tell you you have a 7% growth, okay, you're going to do 100 plus 7. Remember, if I go too fast, just pause the video and catch back up. So 100 plus 7, which gives me 1.0. Whoops, that's 107. I jumped ahead of myself. Okay, now what you're going to do is change it to decimal. The decimal is over here, so you're going to move it 1, 2 to the left, so your multiplier is going to be 1.07. That's what we're looking for today for the first half. Okay, so now we're going to do a 12% growth. So it's going to be 100 plus 12, which is going to give me 112. Again, your decimal is over here, so move it 1, 2. So my multiplier is going to be 1.12. All right, and then let's do one with a decimal. 6.5% growth. A lot of times you guys are going to have decimals with these, so just want to make sure we got this. So 100 plus 6.5, so that's 106.5. Don't round, no dropping off these decimals, guys, we need them. So 1, 2, it's going to put it right over here, so it's 1.065. Okay, no rounding. Okay, so don't ever round that. You got to keep all the numbers there. Okay, they might be annoying, but if you don't put them there, you're going to change the answer. Okay, so now let's do some decay ones. Okay, so remember, decay is going to be less than 1. Nope, that's the wrong way. That way. So the decay is less than 1. All right, so this time you're going to do 100 minus the percentage. That's how we're going to get it less than 1. And then you're going to change to a decimal. Okay, so if I give you a 6% decay, so we're going to do 100 minus 6, so it gives us 94. Okay, decimals over here, go 1, 2. That means our multiplier is going to be 94. All right, so let's try 35% decay. So again, it's a decay, so we're going to do 100 minus 35. Okay. So 100 minus 30 is 70. 70 minus another 5 is going to be 65. But we'll just do it the long way. Okay, most of you guys are going to reach for your calculators. So that's 5. 9 minus 3 is 6. Okay, so again, your decimals over here, move it 1, 2. So 0.65. Now, I do want to show you a decay with a decimal. These can get tricky. So this might be one of the times I'm going to tell you to absolutely use your calculator. So we're going to do 100 minus 0.05. Okay, so grab your calculator. So you have 100 minus 0.05. Let's get it out of the shadow. Okay, so let me do that again for you. 100 minus 0.05. Whoops. Okay, so it gives me 99.95. Again, there's my decimal. Move it over 2, so it'd be 0.9995. That's my multiplier. Okay, so I'm going to give you 4 quick ones to do. Okay, do them, don't do them, that's up to you. So you get a 9% growth, so these are just practice. Okay. A 3% decay, a 7.5% growth, and then I want you to do 5.2% decay. All right, so go ahead and pause the video, see if you get it right, okay, and come back when you're done. So 9% growth, so that's a growth. We're going to go 100 plus 9, so that's 109. Move it 2, you should have 1.09. Okay. Decay would be 100 minus 3, so that's going to give me 97, so 0.97. Okay, 7.5% growth, 100 plus 7.5. Again, you don't have to write this part right here, especially with the growths. You should be able to figure it out. So it's 107.5, so that would be 1.075. And then a 5.2% decay, so 100 minus 5.2. Okay, I'm even going to use my calculator on this one just so I don't get it wrong. Here is more light. 100 minus 5.2. All right, so 94.8. Move the decimal, 0.948. Got them? Okay, hopefully you got them. All right, so now what I want to show you is what it's going to look like when you do the assignment in Delta Math. Yes, you have a Delta Math assignment. You got 3 of them, actually. Okay, so this time what they're going to ask you, is it a growth or decay? And what the percentage is. Okay, so it's going to go backwards. So they're going to give you the equation, okay, and they're going to give you the multiplier. You got to figure out what the percentage is. So here's what it's going to look like. Okay, at the end of the video, I'm going to go back to all the Delta Math questions and show you what they look like and how to make sure you enter everything correctly. Okay, I'm just going to put an X up here because I don't feel like coming up with other random numbers. I got enough numbers to worry about. Okay, so first one to do, figure out is growth or decay. It's greater than 1, so that's a growth, so I'm just going to put a G there. Now, if it's a growth, okay, or if it's a decay, actually, we're going to do this first step for both of them. Move the decimal back. Okay, so we're going to move it back 2 places. So that's going to give me 108. If it's a growth, you're going to do the number minus 100. So it's going to give me 8. So it's an 8% growth. Okay, now the growths are actually pretty easy, guys. As long as you have 2 places here, all it is that number. Okay, so if you had 3 places, you'd actually put the decimal over here. Okay, so you move the decimal back 2 places and then you drop that 1. All right, so that's going to make sense to some of you. Some of you it's not going to make sense to. Okay, so 1.25. Okay, that's again a growth, right? So we're going to do 125 minus 100, which gives me 25%. Okay, now I want you to see this one. So now be careful because some of you guys are going to tell me this is 9. This isn't 9, okay? This was 8. So the difference is I need 2 places here, right? So I only have 1. So I need another place at the back end. So what you're going to do is you're add a second place over there. Okay, so this would actually, it's still a growth because it's greater than 1. So this would actually be 190 minus 100. Okay, so this would actually be 90%. Okay, so watch that. Make sure you got 2 places here. Now, if there was an extra one, like let's say it was 1.375, okay, so you're going to move the decimal back here, okay, and you can actually just take that 1 off. Okay, so this would actually be a growth of 37.5%. So you can actually do that. So move the decimal 2 and take the 1 off. Okay, so that's going to be for growths. Now, decays, okay, they're a little trickier. So if I give you 4 times 0.96 to some random power, right? Okay, so this is going to be a decay. So you're going to do the same thing. You're going to move the decimal back 2 places. So this is going to be 96, right? Okay, but that's not your answer. Okay, you got to do 100 minus 96. and that's going to be 4. So don't forget to do that for decays. You got to do 100 minus the number. For growths, again, you can easily, honestly, growths, guys, just easy to just look at that, okay? But the decays, you got to do 100 minus, all right? So then if I give you 10 times 0.83 to some power, okay, so that's 83, right? Now be careful, that's not the decay rate, okay? You're going to have to do 100 minus 83, which gives me 17%. Okay, what I would do if I was you is go back and check this, okay? So if this is your percent rate, okay, so you're going to kind of go back to what we did over here. Okay, so I have an 17% decay. What would my multiplier be? So it'd be 100 minus 17, so that gives me 83, which is that same number there, okay? So be careful with that. Now, before we get into the word problems, I want to make sure you guys, everybody knows how to use their calculator. Oh, spelled calculator wrong, calculator. All right, so everybody needs to find their calculator. Okay, so get your calculator, find your phone. I got my phone over here. Okay, pull up the calculator on here. Okay, so find your exponent button. Now, you got a couple of choices for your exponent button. It's going to say x to the y, or it might say y to the x. Okay, so here's this calculator. This is one I like to use. Okay, there's the y to the x button. Okay, now on my cell phone, remember you got to turn it sideways, but those of you with Apple phones, remember you have to unlock your phone before you can turn it sideways. Okay, on my phone, it's right there. It's an x to the y. Okay, some of you guys might have a different scientific calculator. It might have what we like to call a caret. Now, there's that other blue calculator that some people have in class. A lot of you guys have that blue one that has the white buttons. It also comes in pink and green. Guys, this is your exponent button, the caret. Okay, so make sure you find that. And then if you use that bigger one, that's the light blue and white. It looks like those yellow ones that we used to have for school. I think it's got an X to a box button. Okay, it may have the caret. I don't really remember, so just look for those. Okay, so if you're unsure, just take your phone, okay, or not your phone, go on Google and Google exponent and then the brand of your calculator, okay? Not my Google, I just asked for Google and Google popped up on my phone, okay? So just let's make sure everybody knows how to do this. So whatever you're gonna use, okay, take it out. So we're gonna go x to the 5th. Okay, so I want you to just figure out what x to the 5th is on your calculator. I'm going to use this one, I'm going to show you on the cell phone. So we're going to do 2, hit the exponent button. Now, nothing's really going to happen on this one. Okay, and then 5 and hit equals. No matter which calculator you have, everybody should have 32. Okay, so if I do it on this one, okay, it's the same thing. So we're going to go, let me get out of the glare. Okay, so we're going to do 2 raised to the, now this one, it comes up with a parenthesis. Now, you don't actually have to close that. Oh, there we go. That's better. Okay, to the 5th. So I don't even have to close that parenthesis, but if I did, there's my parentheses right there. And you're going to see I'm going to get the same answer, 32. Okay, so if I do something like 1.03 to the 4th power, okay, again, so 1.03, hit the exponent button to the 4th power. Okay, you should get this number right here, so 1.1255. Okay. And I can get it the same thing on this one. Let's back that out. So 1.03. We're going to use the exponent button. Whoops. Exponent button to the, what I say, 4th power. And I'm going to get that same answer right there. So 1.125508881. Okay, so make sure you know how to use your calculator. Okay, so again, if you're unsure, just go on Google. Google the name of your calculator and exponent. All right, so now let's talk about word problems. This is the bulk of what we're going to be doing, guys, is word problems. So exponential functions are probably the thing in all of this in all of this algebra 2 stuff that you guys are going to use. Okay, you may not think you're going to use it. Okay, these days you can go on Google and pull up all these formulas that are going to use them, but exponentials are easy, okay? So the biggest one that they use exponential equations for is to predict population. So they take all the data from previous years and kind of figure out a population rate, Okay, so then they can kind of project out the population. So they'll do that. Like every now and then you guys will hear, some of you guys who watch the news, you'll hear about like, oh, the number of people in Palm Beach County grew 1.5% a year, or it's projected to be such and such by the year 2025. Guys, they use an exponential for that. Now, the biggest one, which makes the most sense these days, guys, is doing bacteria and virus, okay, growth rates. Okay, so there are people right now who are using these growth rates and exponential functions to figure out the coronavirus and how fast it's growing, how fast it spreads. They also use it to figure out how long it lives on stuff. So every now and then you hear about how long the coronavirus is living on, maybe something plastic, or it's living on a cardboard box, or it's living on your doorknob or something like that. Okay, so they're actually using exponentials. Now, something else they can actually use it. I'm sure they use many, many other things to do this, but they can use it to kind of project the time of death. Okay, so they can use the rate at which things decay, like bodies decay, okay, to project a time of death. It's not the only way to do it. I'm sure they do it many other ways. Now, the thing that's going to be the most relevant to you guys is interest. Okay, some of you guys are saving money now. Some of you guys are going to be saving money soon, whether it's for a car or, I don't know, some new tech thing, some new Apple thing. Eventually, you guys are going to hopefully start saving for your retirement. Okay, so your interest rates and how much interest you make on investments, okay, that's what this is. We're going to talk about those probably on Wednesday. Okay, so that's something a little easier. Now, the big thing, this is the important part of all of this, okay, is how do we use this stuff? So there's not really a formula that's actually written out. Like, Pythagorean, we have a squared plus b squared equals c squared in quadratic formula. This is just one, I kind of put it together on my own, but it's the same idea. You're going to take the original amount, so however many of whatever it is you start with. Then you're going to do the multiplier, and you're going to raise it to the time power. Okay, we're going to do some of this stuff. So you do the original times the multiplier, which is raised to the time power. Now, the time has to be the same units. Okay, so if it says it's percent per day, and then it asks you about how many months out it is, okay, or if it asks you like it's 2% a day, and then it says how many will there be in a month. Okay, remember you got to convert it to days. So this has to be the same unit as your percentage. Okay, so be careful with that. All right, so I got some word problems here. Okay, again, just hit the pause button, okay, if you need some more time to write. All right, it says, a doctor gives a patient 250 milligrams of an antibiotic. That actually should be one word. Okay, so make sure you make that one word. That is eliminated from the bloodstream at a rate of 15% per hour. How many milligrams to the nearest hundredth are remaining after 3 hours? Okay, so the first thing I want you to do is decide whether it's growth or decay. So G or D, growth or decay. This is not all that important, but you need to do it so you can find the other thing, okay? So now, growth or decay. So we want to know, it says it's eliminated from the bloodstream at 15%. So it's eliminated. Guys, that's going to be decay, all right? So now we're going to use that for the second thing, which is find our multiplier. Okay, so we're going to decay, so we're going to do 100 minus, and then there's my percentage, right? 15. So 100 minus 15 is going to give us 85. Move the decimal over, so our multiplier is going to be 85. Okay, so now we got our original amount, which is 250, right? So 250 times our multiplier, so 0.85. Now raise it to the time power. So it's 15% per hour for 3 hours. Now these match, so we're okay. So how many hours are in 3 hours? The answer is 3. Okay, so that's your equation. Now, you need to find the answer. Okay, so remember you're doing PEMDAS. Okay, so remember exponents come before multiplication, so you're always going to do this part first. Okay, so we're going to do 0.85, and we're going to raise it to the third power. So we got that number. Now, don't clear that number out, guys. Leave that there. Okay, now you're going to multiply times 250. Now, I'm going to write this whole thing down, but that whole thing is not the answer. 153.53 63125. Okay, so I want you to make sure you go back to the problem and read the units. So this is nearest hundredth with the TH on the end, which means the decimal place. So remember, this is tens, this is hundredths, so we're looking here. Go behind it, that number is a 1, which means this stays. So your answer is going to be 153.53. So there's 153.53 milligrams left after 3 hours. Okay, so let's try the next one. Again, if you need time to write, just pause the video and come back. It says the population of a city was 450,000 in 2019. This is 2019. Okay, if the population increases at a rate of 2.3% a year, what will the population be in 2025 to the nearest 10,000? So I gave you what I want you to round it to. Okay, so again, growth or decay, this is increases, so it's a growth. Okay, so now you're going to do 100 plus the percentage, so 2.3. So it's going to give us 102.3, move the decimal over, so 1.023. Okay, so that's my multiplier. So use your original amount, so 450,000 times 1.023. Okay, it's a year, so I got to figure out how many years is it from 2019 to 2025. So 2025 minus 2019, that's 6 years. So that's going to be a 6 up there. Okay, so again, do your exponent first. So 1.023 to the 6th power. So 1.023. Again, make sure that you typed it in right. To the 6th power gives me that big long decimal number. All right, now times that by 450,000. Again, and double check it. So I need one more 0. Okay, so now it's 450,000. Hit enter. So again, I'm going to write that whole number down. So I got 515,782.1594. All right, so the nearest 10,000, there's no TH on the end, so that means I'm going on this side. So ones, tens, hundreds, thousands, 10,000s are going to that number. Okay, so look behind it, it's a 5. Remember, 5 and higher just jump. So this is 520,000. So 520,000 is my answer for that. Okay, so in 2025, there'll be about 520,000 people in this city. All right, let's do another one. Okay, we only got a few more, don't worry. Okay, see, that's it. And then one on the back, real quick. All right, and the population of a city in 2015 was 1 million. Oh, let me move it down. Population of a city in 2015 was 1,215,112. Population grows at a rate of 5% a decade. What will the population be in 2025? So I use 2025 again. Okay, so the population is growing. Again, pause it if you need more time. Okay, so we're going to do 100 plus 5, which gives me 105, so 1.05. Okay, so we need our original amount. Make sure you copy that number down right. Our multiplier. Now, I need to know that number up there. So a lot of you guys are going to go, well, 2015 to 2025 is 10, so I'm going to put a 10 up here. No, it's not a 10, so be careful, okay, because it says 5% a decade. Okay, how many years are in a decade, do you know? It's 10. Okay, so what we're going to do is, so 2025, we're going to subtract it the same way we did. Okay, but this is 10 years. So I want to know how many decades is that? Okay, so 10 years is 1 decade. So guys, this exponent up here is going to be a 1. So be careful with that. So you got to make sure that this unit matches that unit up there. Okay, because if you would have put a 10 up here, that would have been 10 decades, which would have been 100 years. Okay, now I'm going to break out the calculator again. Now, some of you guys know that 1.05 to the first power is still going to be 1.05. That makes you feel good, put it in the calculator anyway. So 1.05 raised to the first power. Right? Then we're going to multiply it times the original amount. Let me move this bit. So 1215112, 1215112, and hit enter. Okay. So we got 1275867.6. Now I didn't tell you what to round this to, but it's people, guys. So you're going to go to the whole number. Okay. So that's a 6. So jump that up. So 1275868. So 1,275,868. Okay, so now I'm going to do one more thing with this, just to make sure you guys know what's going on. So what if I tell you, or ask you, how many more people will there be in 2040? Okay, so we're going to kind of do two things in here at once. So this time I want to know how many more people there were. Okay, I don't want to know what the total is in 2040. I want to know how many more people there are than there were in 2015. So you're going to do the same thing. Okay, so the multiplier is the same, the original amount's the same. So you got 1215, 112, 1.05. Now we're going to do 2040 minus 2015. Okay, so that's 3, that's 1, that's 5, that's 25. Okay, so this is 25 years, but it's going to be 2.5 decades. So that's going to be a 2.5 up there. Okay, so we're going to figure this out. So everything so far is the same. So 1.05 raised to the 2.5 power. Okay, oh, that was pretty nice. Let me try it again. 1.05 raised to the 2.5 power. Now I got two different answers. Yeah, that looks better. Okay. So if you ever get two different answers when you try it again, do it a third time so you figure out which one was right. Okay. Now we're going to multiply that times the original. So 1215, 112. Okay. So I get this big long number, right? So 13,72740. 11. Okay, the decimal's after the 4. That doesn't seem right, because that's less people. Okay, so 1.05 raised to the 2.5 power times 1215112. 13727. Oh, I forgot a 4. That's better. Okay, so 1372744. That's a little better. Okay, so now I can round this and that's fine. Okay, that's a 4. This is a 0, so that really kind of just goes away. Remember, if this number behind it is less than 5, it stays. But that's not the answer. Okay, I want to know how many more people. So what we're going to do is we're going to subtract. So 1, 2, 1, 5, 1, 1, 2. So take this number. Okay, so you subtract the original. So 1, 2, 1, 5, 1, 1, 2. So I get 157,632. Okay, so there's 157,632 more people. So be careful. Whatever asks you more, okay, then you're going to have to do the subtraction. All right, let's finish this up with this last part. Okay, then I'll get to the delta math. All right, so real quick, guys, some quick things. Okay, so what's going to happen sometimes they're going to have random things. Okay, so it's not going to give you a percentage. It may tell you that the growth is going to double. Okay, guys, that just means it increases 100%. So it's really 100 plus 100, which is 200, or just 2. Okay, guys, double is 2. Okay, so you multiply it times 2. Okay, so think about it. If I double 3, what do I get? I get 3 times 2, which is 6, right? Triple, I'm going to save you all this inside here. Just get to it. Triple is going to be a 3 for the multiplier. Okay, and then if it says something like a half-life, guys, that's going to be 0.5 because it's going to be half. Okay, a half-life you usually hear in chemistry. Okay, it just means that that's how long it takes for half of it to disappear. So you're just going to use 0.5, and this is going to be a decay. Okay, these two are growth. This one's going to be a decay, so be careful. All right, so if I got 55 bacteria, then they're going to double every hour. All right, so I want to know how many are going to be in 5 hours. Okay, so there's my key word, it doubles, right? That means it's going to get bigger. So we're going to do 55 times 2. Okay, every hour, I want 5 hours, so it's going to be a 5. Okay, so we're going to do 2 to the 5th power. Okay, it's 32 times 55. So this is going to be 1760. Okay, so if I tell you I have 75 bacteria, and they're going to double every 30 minutes, Okay, and I want to know how many in 4 hours. Okay, so we got 75, they're going to double, so the multiplier is 2. Now, be careful here, this number up here is not 4, so it's kind of like the decade one. This doubles every 30 minutes. So what you really want to know is how many 30 minutes in 4 hours. Okay, so there's 2 30 minutes in an hour. Okay, so 2 times 4 is going to give me 8. Okay, so 2 to the 8th. Get that, and then multiply that times 75. So your answer is going to be 19,200. Okay, now let's do this last one. Okay, so if I got 150 bacteria and they triple every 15 minutes. Okay, and I want to know how many in 3 hours. Okay, so 150, we're going to triple, so we're going to use 3. Now, okay, there are 15 minutes, so how many 15 minutes in 4 hours? Okay, there's 4 15 minutes in 1 hour. Okay, so we're going to multiply that times 3, so this is going to be 12. This is going to be a really big number. Guys, you're going to get big numbers on things like this, so just be aware. So 3 raised to the 12th power, okay, times 150. 797,16150. 79,716,150. That's a lot of bacteria. Okay. All right. So let's go quick over to the delta math. We're almost done. Let me switch the screens. Okay. So here's your first delta math one. All right. So given the following exponential function, identify whether the change represents growth or decay, and then determine the percentage rate increase or decrease. So we're going to look at. Let me get my pointer out. That's how I figured out that I paused before, never unpaused. Okay, so it's 1.07, so that's greater than 1. Okay, so that means this is going to be a growth, so we're okay. Now remember, for growth, we did 107 minus 100. So remember, or it's just this number right here, right? This 2-digit number. Can we get it? There we go. Okay, so it's just going to be 7. Submit your answer. Do you like this answer? Yes. Oh, look, we got it right. Now, there's a little different roundabout way that they did it, but it's the same idea. Okay, let's find one. No, not that one. Let's do another one. Okay, nope, this one's fine. It changed. Okay, so this one you got to figure out as a growth or decay, so it's less than 1. Okay, so that's going to be a decay. So remember, you're looking at this number right here. That's a really bad circle I did over there. Okay, so now you're going to do decay. So let me switch back to the screen over here. So it was 90.98. So you're going to do 100 minus 98, which is going to give me 2. Okay, so let's go back. Oh, come on. Okay, so let's go 2%. Submit it. Do you want to? Yes. Okay, so we got it right. Good job. All right, so that's that part. You'll have 5 of those. Remember, you got to get a total of 5. You have to have a score of 5. Okay, so what's going to happen, you have the record at the top, then you have a score and a penalty. Now, the penalty is that every time you get one wrong, you lose 1 off your score. So if you had 3 right, okay, 3, and you miss 1, it's going to drop your score back down to 2. Okay, so now you still need to answer 3 more to get back to 5. Okay, so somebody was asking me, do I have to get 5 in a row? No, you don't have to have 5 in a row. You just have to be careful. You miss one and you miss another, you're going to get things wrong. Okay, so let's look at this one now. A new car is purchased at $16,400. The value of the car depreciates at 12.5% per year. Okay, what will the value be of the car to the nearest cent? So we got $16,400. Okay, it depreciates. That means it loses value, guys. 12.5% a year. Okay, and I want to know for 8 years. Okay, so let's jump back to the screen so you guys can see. So it depreciates, which is a decay of 12.5%. So we're going to do 100 minus 12.5. Okay. Actually, what I want to do is let's do this so you can see it on here. So up here is a calculator. Okay. So use that calculator. Okay. So if I hit the calculator, okay. So right here, see it down here? Okay, that's supposed to be now. Pops up the calculator. So you can do everything right here. So you can do 100 minus 12.5. Okay, so now the answer is all the way over here right above my head, so that's 8.75. Okay, so 87.5. Okay, so then you got to make sure you move the decimal over. Okay, so let's switch back. So it's going to be 0.875. Okay, so your equation is going to be 16,400. Okay, 0.875. Now it's per year for 8 years, so this is still going to be an 8. Okay, so now you can either do this on your calculator or just be careful. You can actually do it in that calculator that's on the Delta Math. So if I go over here, but make sure you do the exponent part first. So 0.875, whoops. Okay, raised to the, remember this is what you guys were missing on the other one, right here. There's your exponent button. Raised to the 8th power. Now, you guys are going to have to arrow over. Now, you're going to have to kind of do this all in one, but make sure it drops down. And then you're going to do times, okay, the original, so 16,400. Enter. Okay, so your answer is all the way over here. Now, be careful. You want to round that to the nearest cent. Okay, so money is 2 decimal places. So let me drop you back over here. Okay, so we're over here. So we got to go to this over here. So that 6 should jump this to a 9. So 565.19. Okay. So, oops, let's get done with that. Go back up here. So right here, the X, you can actually cancel that. You should be able to clear that out. It doesn't want to go away right now. Okay, so. All right, so my answer, you got 5,635.19. All right, let's see if we did this right. Submit. Yes. Okay, your answer's right. This should, if you want to go away, just click the calculator button. So we got that right. Okay, so you guys got that one. Okay, now let's look at this last one right here. Calculator, go away. Okay, so this one I want you to be careful with. So $49,000, okay, over time it depreciates by 1/2, so that's going to be a decay, okay, so that's where we're going to use 0.5 every 5 years, okay, so it's half, okay, for 5 years. Now, they want to know what the value of the car is after 21 years. Okay, so we'll switch it back over here so you guys can see this. Okay, so right up here. So you want it for 21 years and 5 years. So they want to know how many 5-year spans are in 21. All you're really going to do is take this number and put it over this number. So 21 divided by 5. That's going to be your exponent. Okay, now I want you to leave it as a fraction up there because, you know, if you divide it, it might not round nicely. Okay, so there's one I did earlier that was like 9 divided by 6 and it gave me, you know, a repeating decimal. So just leave it like this. Okay, so the easiest way is actually go back and put that in the calculator. So open up your calculator. Okay, so you see I got it over here already now. Let me back it up so you can see how I entered it. Okay, so we're going to go 0.5, hit your exponent button. Okay, so now it jumped up. Okay, keep pointing at the screen right there. You see how it jumped up right there? Okay, so now we're just going to do the fraction. So 21 divided by 5. So you see it's up there in the fraction. Okay, arrow over, now times the amount, the original amount. Okay, so if you look over here, this is what the equation was, right? So we're going to do this part first and then times it by that. Okay, to the nearest $100. Okay, so be careful with that. Okay, so we're going to move my face because it's in the way. So I got 2666.0611. Okay, so I got to get this to the nearest $100. So that's that spot right there. So this should be 2700. Okay, let's make sure we did that right. All right, let's go back up here. Let's close the calculator. Okay, so 2700. Submit it. Yes, we got it right. Okay. So let's do another one. Okay, so the lab experiment, 2,200 bacteria placed in a petri dish. Okay, the conditions are that the number of bacteria will double every 6 hours. How many bacteria would there be after 13 hours? Okay, so this number, the number that you have right here, that's the number you want. How many hours you want, that number has to go on top. Okay, so we got 2,200. Now they double. Okay, I'm going to show you what I'm writing in a minute. Okay, 2. And then it's every 6 hours for 13 hours. Okay, so I'm going to jump back so you guys can see what I'm writing. So 6 hours for 13 hours. So remember, this number goes on top. Doesn't matter if this one's smaller. Okay, so if it would have been 6 hours, for, 3 hours, okay, it would be 3 over 6. Okay, so be careful. So we got that. So let's go back. Okay, I want my answer. Let's pull out the calculator first. Okay, back that out. So we're going to double. So 2 raised to the 13 divided by 6. Arrow over, so it drops down, so it's even with the 2. And then times 2,200. Okay, so my answer to the nearest whole number, so I got 9,877.666,025. So whole number, guys, that means the ones place. So up. So we're going here. So again, that 6 is going to make this jump. Remember, 5 and higher, this jumps. 4 and lower, this stays the same. So 9,878. Okay, let's go back. Close out the calculator. 9,878. Submit the answer. Yes, and we got it right. Okay, so you guys are going to have until Tuesday night to get this done. So there's three different sections. So get them done. Okay. Hopefully everything's fine. As always, if you need me, text me on Remind, and if we need to, we'll jump on Google Meets to answer your questions if they can't be answered in text. All right. It's been great. Good luck. See you guys on Wednesday.